So last time we had just introduced the idea of double replacement reactions, and we had talked about the fact that there are three driving forces. We can form a precipitate or a solid, we can form a weak electrolyte, or we can form a gas. And we looked at some examples where we traded partners at the dance and we made a solid. And as a student, what you have to do is to study those solubility rules until you know them cold. That you can glance at something and say, okay, that's a solid, and you recognize it as such, and you know then that's the chemistry going on. I'm making a solid. The next criteria is the formation of a weak electrolyte. Often this weak electrolyte is water. It could also be any weak acid. Now, how do we recognize a weak acid to know it's a weak electrolyte? Because it's not strong. We have a list of 7 strong acids, and anything not on that list is weak. That's how we recognize it. So let's look at some examples. I have magnesium hydroxide, solid, sitting in my beaker. I dump a little HCl in there, and just like before, they trade partners at the dance. Magnesium's a +2 ion, chloride is a -1, so we write the proper formula, MgCl2. Then hydrogen hooks up with hydroxide, HOH becomes water, H2O. Now we look at this, and the next step is to balance our equation. So we look at this and say, well, I have 2 hydroxides over here and only 1, so I'll put a 2 in front of my water. I already had the 2 in front of HCl. So now I have a balanced equation. Now we need to put our subscripts in for physical state. MgCl2. Well, I don't really know any rules about magnesium, but I know chloride is usually soluble unless it's hooked up with silver, lead 2, or mercury 1. This is magnesium, not silver, lead, or mercury, so this will be aqueous. And we use the AQ subscript because it's dissolved. Then water is a liquid. So I made water a weak electrolyte, so I have real chemistry. Okay, here's another example. Iron 3 oxide reacts with hydrochloric acid. So I trade partners. Iron 3 hooks up with chloride. I make the proper formula for iron 3 chloride, FeCl3. Then hydrogen hooks up with oxygen. Again, I make water, H2O. So now I have 2 hydrogens here. I had 6 in here to help us, so I make 3 waters, and I need 2 iron 3 chloride to make both the iron and the chlorine balance. Now we add in our subscripts. What subscript do I use for iron 3 chloride, class? Aqueous. And what for water? Liquid. So I made the same weak electrolyte water. Acetic acid plus sodium hydroxide. Trade partners at the dance. I make sodium acetate, NaC2H3O2, plus water, H2O. Now we check and everything is already balanced. It's 1-to-1 stoichiometry. Sodium and acetate are both on the soluble list, so these become aqueous and water is a liquid. So in each case, I made water a weak electrolyte, and that is a driving force to say that real chemistry has taken place. Now let's look at the last example, where we deal with gases. This is the trickiest one because this is material you really have to study and practice and learn so that you recognize these combinations of ions and the gases they form. We can produce gases by the combination of a couple of ions or by the decompositions of weak acids or weak bases. So if we have hydrogen ions reacting with sulfide ions, we make hydrogen sulfide gas. You know this gas, it's the rotten egg smell. So you're familiar with that from everyday life. Hydrogen plus cyanide makes hydrogen cyanide gas. I hope you're not familiar with that from everyday life. Hydrogen cyanide gas is what they use in the gas chambers, right, for capital punishment. Does anybody know what this smells like? What? No, not flatulence. It smells, well, I'll tell you what it smells like. So, I went to Fashion Square Mall with my family. This happened when they were young. I had 2 young children and baby in the stroller. So Bob was with me. We're walking through the mall. You know Fashion Square Mall. We went in through Sears, walked out of Sears into the mall. If you just get away from Sears a little bit, you can turn left and there is an exit that goes out into the parking lot. So we had parked at the end of the building by Sears. We go in, we're talking, got the baby in the stroller. 2 older children have 1 hand each on the stroller. That's the instructions, so they're not wandering around in the mall. And all of a sudden we go out and we're just talking and it hit me. I smelled hydrogen cyanide gas. And I'm like, oh my God. And I just started to panic thinking the terrorists had struck Fashion Square Mall. So I reached over, I take my hand, throw it over the baby's mouth and nose. I'm holding the baby's nose closed. I got her mouth covered with my hand. Her arms are going up in the air like, what are you doing, Mom? And I'm like, oh my God. And I start running for the exit left out of there. And Bob's like, what are you doing? And I'm like, don't you smell it? We got to get out of here. And Bob says, and I'm like, don't do that. And my 2 older kids are like, babies, can't breathe. I'm like, don't breathe. Hold your breath. We got to get out of here. And I'm trying to run for the exit. Got 2 kids hanging on the stroller. Bob grabs my arm. He spins me around. He's like, what is wrong with you? Like, we have to get out of here now. He says, what is your problem? I'm like, can't you smell it? I'm almost in tears. I'm so frightened for my children and my family. And he's doing this again. I'm like, don't do that. I'm like, just hold your breath. We have to get out. I'll explain in the parking lot. So he grabs a hold of me and just turns me around. He's like, you need to calm down. Stop this and calm down. And I'm like, but I can smell hydrogen cyanide gas. He does it again. And then he turns me around. He's like, look over there. Hydrogen cyanide gas smells like roasted almonds. I turn around, there's some idiot over there cooking nuts at a little kiosk in the Fashion Square Mall. That didn't used to be there, right? So they're roasting almonds in there, selling those little candied almonds, you know, in the little cone thing, the little paper cone. I'm like, when did that come in here? There was no nut roasting going on the last time I'd been in the mall. I thought the terrorists had struck. So, if you're in the mall or at the soccer game and they're roasting nuts, probably okay. However, if I were a terrorist, that's where I would release the hydrogen cyanide, right next to the roasting nut house. Because then you'd get everybody, right? Not that you should do that. But you start to think, when you start to think like a chemist, you got to be a little careful. Sometimes you might overreact in a situation. Okay, so hydrogen cyanide gas smells like almonds. If you're in the lab ever and you smell that, you really do need to get out. And I have smelled it, and it really does smell like almonds. And it is detectable to the human nose at very low thresholds. So you can smell it before you're in trouble. So you just get out of there. With your roasting nuts, right? So the last one is ammonium works with hydroxide, and this makes ammonium hydroxide, which breaks down and gives us water plus ammonia gas. So these are things that you now are responsible to know, which means you study, practice, learn, so you recognize these. Now the next 2 gases we're going to look at are a little trickier because we don't recognize a gas at first. If we have hydrogen hooking up with carbonate or hydrogen hooking up with hydrogen carbonate, we make carbonic acid. Carbonic acid spontaneously decomposes to make water and carbon dioxide. If I open that bottle of Diet Coke, it'll go flat because the carbon dioxide is bubbling away. It's leaving the solution. So when we have these 2 combinations of ions, we make water and CO2. We have a similar thing happening down here with sulfite and hydrogen sulfite. If we get hydrogen plus sulfite, we make sulfurous acid, which then breaks down to give us water and sulfur dioxide gas. Same thing with hydrogen and hydrogen sulfite. So these gases are additional ones you have to remember. So now let's look at some examples. Okay, we have some examples of double replacement where we make a gas. So we have calcium carbonate reacting with hydrochloric acid. We trade partners. Calcium hooks up with chloride, CaCl2. Hydrogen hooks up with carbonate, H2CO3. Oh wait, that's one of the funny ones. So this actually breaks down, and what I really get is water plus CO2. So now we check our equation to make sure it's balanced. I already put the 2HCl in there. So I have 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens, 3 oxygens, 1 plus 2 is 3, 1 carbon, 1 carbon. So I'm balanced. Now I put in my subscripts. Calcium chloride. Chlorides are soluble. It's not silver, lead, or mercury. It's calcium. So this is aqueous. Water is a liquid. Carbon dioxide is a gas. So I kind of got a 2-for-1 deal in there. Let's look at the next one. Ammonium chloride and sodium hydroxide. I make sodium chloride plus ammonium hydroxide. Ammonium hydroxide breaks apart, and what I really get is water plus ammonia, gas. Water is a liquid. Sodium chloride is aqueous. Potassium cyanide and HCl. I make HCN, which I recognize as that almond gas, plus potassium chloride. Potassium chloride dissolves readily. That's what they use to stop your heart for heart surgery. They overload you with potassium chloride. It stops your heart. Calcium sulfite plus HCl. I make calcium chloride, write the proper formula, plus sulfurous acid. Oh yeah, one of the funny ones. What I really get is water and SO2. This is a gas, a liquid, and aqueous, and I'm already balanced because I had the 2 in there. So those are examples of all 3 types of metathesis reactions.